Okay, hello with everybody. We are the group 6 and we want to talk about our project. First of all, we have the background. Okay, the purpose of this project is to design a drinking water system for the residential use and the same form they calculate the design for the sanitary drainage and rainwater system. The project also includes the design of electrical system, both power supply the home and the power supply to each device within the residence. The residence is in Town San Borondon, within the Aires de Batán urbanization, stage 1, and solar 94, occupying a land area of 509.98 square meters. The standard that we use in this project are NEC, and JPC. Okay, continue about the domestic water supply. The water that we will be obtained from the Guaira River with the help of Interagua plants, which agrees with the Amagua company, Agua San Borondon, a mixed company provides a drinking water and a sewage service in La Puntilla Parish, in San Borondon town, and the same for in La Guaira Parish in Taulet town. Okay, about the fixtures and pipe. After the potable water piping layout, all the instantaneous flow rates were added together to obtain the total discharge to supply by the pump. After that, we have this information, the total instantaneous flow with 3.1 liters per second, and total plumbing fixtures that we use in this project are 23. The simultaneous coefficient for the pump is 0.213. Okay, after that, finally, using the maximum probable flow rate and velocity recommended by regulation, in this case, for the neck is 1.5 meters per second. We have the diameter of the pump pipe. And the same form with this information, we calculate the diameter for the diameter of the pipes for each branch. And the same form, the diameter for accessories and the fixtures. Obtaining the water demand for habitant in the house, the total storage is 2,400 liters. We have a system with 2 meters of height and 3.6 meters wide with 3.6 meters for longitude. Obtaining a total of 28.88 cubic meters. And now to service the house with water for an extra demand. In this project, we use different fixtures, for example, elbows and teeth. Okay, continue with the technical specifications. We have this information to the project for different accessories or fixtures, for example, for pipes, for elbows, and for teeth with different diameters. And we have the information like temperature, continuous service time, and nominal pressure. Thanks.
Continue with the pump data share. The selection of the pump based off the calculation of losses of each pipe. We end up by the selection of the PK100 pump. Now this pump has the motor connection of 3-phase, motor 1.5 horsepower, 6.2 amperes as an absorption, 3.6 an absorption of 400 of voltage, 1 inch of suction mouth, 1 inch of delivery port, body pump, impeller, and number of impellers, motor shaft, check valve, it doesn't have, degree of protection, flow rate minimum, and maximum flow 5 and 70 each one, a minimum head of 15, employments, well, water supply, motor voltage, weight, and guarantee of 2 years. Now, by the cost estimate, more than the fixtures we previously taught, we have the length of the piping by this cost analysis per unit. we multiply as the units we need. For example, we need from the tubo PVC, it is sold by 6 meters. So if we need 24 of them, 24 of those 6 meters, multiplying by that, by the unitary cost, we have the total cost. Also, it includes the pump and other equipments like the terradas, ending up in a total of $903.82. Now in the drawings, we make two schedules, one in AutoCAD and the other one in Revit. First one, we did a preliminary drawing in AutoCAD, which was way easier. This helped us locating where the pump is going to be, where each fixture is going to be, depending on the room and its utility and its function. And later on, by the architectural drawing, we add of sanitary potable systems, the fixtures and the piping. Here we can appreciate the piping and the fixtures connecting each one, providing each one with drinking water. Now, for the sanitary drainage system, we have, well, this is the domestic water generated by human consumption. In the present, residents will be evacuated through a drainage system consisting of siphons, sewage pipes, both collectors and downspouts, ventilation system for odors, and expansion boxes. Now, this calculation was made up by each fixture, and we have a minimum of diameter from each plant, ending up in a downspout depending on the total of the units, the UEH. As well as in the plan one, we base off from the same calculation. Now for the collectors of each plant, this needs to fulfill a requirement, which is getting the relationship between the elevation of water compared to the diameter of the piping, and it has, we can say that all of these were correctly checked. For example, we can see here that for the room of the bathroom one, the relationship ending in 0.561, it was less than 0.75, which was the maximum. So this is correct. And for each one, for each room, as long as we are collecting more units, it also depends on the units accumulative.
Here we can see the ventilation system specifications. All ventilation systems were assumed within a 2 inches diameter, which is equal to 50 millimeters, connecting each plumbing fixture pipe where it ends up on 3 sanitary caps on the roof. Ventilation system of the plant one, all diameters 15 millimeters. Of the plant two, all diameters of 15 millimeters, with a total length of ventilations pipes that 75 meters approximately. Here we can see all the elements that are considered for the cost estimate of the sanitary drainage system. We have 13 items were considered. Among them are elbows, reducers, grids, etc., making a total of $724 with 16 cents. We can see here we can see for the stormwater drainage system that the roof was divided into 2 areas. The first of 131.42 square meters, from which it was obtained that the flow is 3.65 liters per second with a slope of 1%. The second area was 107.35 square meters with a flow rate of 2.98 liters per second. For both cases, it was found that the appropriate pipe should be 4 inches. The total cost of the water drainage system is $442 with 8 cents, where the most expensive were the cannelon, because we have 12 cannelons with a unit price of $28 with 46 cents. This image show the isometry and plan view of the water drainage system. You can see to the east, the pipe right there, the pipe going down and the gutters in the perimeter. In the software Revit, we put the ceiling with the slopes. The slope was 1%, and then the gutter in the perimeter of the roof, and then the downspouts to the floor.
Hi, my name is Victor Ulloa, and in this part of the project, electric system demand analysis and supply. It's okay. We did a device where electrical outlets, air conditioning, lightings. For supply, the electrical supply of the main panel bar is given from wires number 6, having a total three wires, which are 2 wires of type line number 6 and 1 neutral number 8 AWG from empty pipe. The panel bar will be with a minimum 1/16 metal sheet, duly treated and painted with a baking process, and inside will contain 1 class 200 3-phase socket bases in space for the main 3-phase as a circuit breaker. This wire is located on the pole by metal clamps for its fastening as detailed in the corresponding the residential house with the characteristics and dimensions according to specified to the NAS. Receives the secondary feeder and distributed electric energy to each internal and external area of the home. The electrical distribution panel with house deploying protection breaker, it must be properly envid, and I will for a service voltage of 127 at 220 volts AC. Its location in the arrangement of the protection and control elements are detailed technical specification. Then technical specifications and meant conduits, hub, galvanized electrical rigid conduit, has excellent protection strength, septic ductility. with high strain steel and produce electric resistance welding process. In our scopes, application standards, general construction requires of HDE rigid PVC pipe material should be strictly supply conformance standards. Dimensions, colors, and weld thickness and length. For this part, we use to dot 5 meter with tolerance 10 millimeters. In co-system electrical system, we have an elbows conduit, PVC, pipes conduit, root, copper well, incandescent lightings, and electrical outlet. For this total cost, we have 764 around. For drivings, we relicensed a preliminary location of luminaries and electrical outlets was made in AutoCAD, and then the installations were made in Revit for 3D.